In this video, we're going to take a look at applications of volume of 3D figures. So for example 1, it asks us to find the volume of a cone with a diameter of 20 centimeters and a height of 7 centimeters. So I like to draw as best I can a picture of what they're talking about. So here is a cone, and we could add a diameter of 20 centimeters and a height of 7 centimeters. And then we want the volume formula for a cone. So that is 1/3 of the volume of a cylinder, which is pi r squared times the height. So then we just need to fill in what we know. So we know the diameter is 20 centimeters, but we need the radius. And the radius is half of the diameter, so that would be 10 centimeters. And then our height is 7 centimeters. So let's fill in the volume is 1/3. For these examples, I am going to use pi is equal to 3.14, but you do have a pi button on your calculator and you have one in Desmos, so you could use that to get a little bit more accurate of an answer. But just to keep things consistent, I'm going to use 3.14 for my calculations. All right, so I'm filling in the radius is 10, and I need to square that, and then multiply by the height, which is 7. Once you type all of that in your calculator, you should get 732.6 repeating. So I'm going to say 0.67 cubic centimeters. All right, so let's take a look at number 2. It says find the volume of a rectangular prism. A rectangular prism is a fancy word for a box. And it measures 10 meters and 5 meters along the base and 12 meters tall. So I'm just going to sketch a box and label it and find the volume of it. All right, so the base is 10 meters by 5 meters and the height was 12 meters. So for the volume of any kind of prism, it's equal to the area of the base, which we use a capital letter B to represent that. So area of the base is that big B, and then you multiply by the height. And that breaks down into the area of this base of this box is just length times width. So length times width times height comes from the area of the base times the height. And so we can just put all that together. So 10 times 5 times 12 will give us a volume of 600 meters cubed for this example. All right, so let's look at one more example of these type of problems, and then for honors you're going to have a few extra examples in a separate video. So Abigail has a cylindrical candle mold shown below. She has a rectangular block of wax measuring 12 centimeters by 15 centimeters by 18 centimeters, and we want to know how many candles can Abigail make using the wax and her mold, and then how much would be left over, if any. So if we assume Abigail has this block of wax, I'm just going to draw a block of her wax, and it measures 12 centimeters by 15 centimeters by 18 centimeters. We could figure out how much the total volume is for her wax by saying that that would be the area of the base times the height, which is the same thing as saying length times width times height, which would be 12 times 15. Let me fix that. 12 times 15 times 18. So the total volume for all of the wax would be 1,440 cubic centimeters. So I'm just going to write that that's the total amount of wax. And then we got to figure out the amount of wax each candle would need. So that's the volume of a cylinder. So the volume of a cylinder is pi r squared times the height. Notice that's the area of the base. The base of a cylinder is a circle. So the area of a circle is pi r squared, and then we're multiplying it by the height since the volume is a 3D measurement. So pi, I'm just going to use 3.14 again. The radius was given it's a little blurry, so I'm just going to rewrite that, is 3.4. So we need to square that and then multiply by the height. Again, that's a little blurry, but that looks like 6 centimeters. So the volume of each candle comes out to 217.8 cubic centimeters. And so let's write down, that's the wax per candle that we would need. And so let's look at the question again. It says, how many candles can Abigail make using the wax and her mold? So we need to take our total volume over here and divide it by the wax it would take per candle. So 1,440 divided by 217.8 gives us 6.6. So that means Abigail can make 6 candles. And then it asked how much would be left over, if any. So the 0.6 is how much is left. So if she can make 6.6 candles, then she will have 0.6 times the amount per candle, which is 217.8 cubic centimeters of wax left over, which is 130.7 cubic centimeters left over. All right, so that's it for these examples. Again, honors, you need to tune in to the next video to get a few more examples. Thanks for listening.